Well, welcome to mid-December. That means it is time to update my winter weather forecast I made back in October. That forecast is down in the description below that I made at a local weather conference. If anyone does not want to look over the methods, I will have timestamps of when you should go for each bit, with one specifically for the forecasts. First off, there's this little disclaimer, aka the legal stuff I need to say. I'll go through this quickly. This is a long-range forecast, and as a result, is bound to have some forecast error. Always seek official information from the National Weather Service or any local news stations. Also, no weather modelers are taken into consideration unless otherwise said. Okay, now that the legal stuff is out of the way, I will be talking more slowly as we go into the methods and review. So first off, really none of my methods have changed in terms of the major oscillations. Again, I'll note that my analog years, I do not weight them equally. The analogs that are closer condition-wise to this year have a much higher weighting than those that are further away. I also cut away some analog years that I used in October and added one back that I did not have in the original October forecast. The statistical analysis really hasn't changed either, with the exception being that in the December update, I do take into account the current conditions thus far and any trends that have resulted in those conditions. And then, just as a note, I do adjust the snow totals of each year prior to the 1970s to a 4.3-inch average per winter, which has matched the snow totals since the 1970s. Also, as a note, I try to put each forecast into about 1/3 of all winters. The general choices are below average, a near average, or an above average winter, or some combination of two of the three. Subcategory of above average you'll hear me use later in this forecast is a hyperactive season. That is being defined as the top 10% wettest water years or the snowiest winters. For reference, the water year runs from October 1st to September 30th. So, moving on to the data and other factors to consider. We have moved further into La Nina in terms of the October, and it's not shown, but it's starting to flatten off a little bit as we've gotten into November. And the Climate Prediction Center forecasts are still a little bit all over the place. However, there's a general agreement it will be in the weak to moderate La Nina range. The CFS is further into the moderate La Nina range. However, the NOAA model is still an outlier in terms of how far into La Nina it goes. The main run is still in the strong La Nina category. However, the most of the rest of the world and major models are saying probably around that weak to moderate La Nina borderline area, which is what I'm going for my forecast. Southern Oscillation Index supports this. It has been fluctuating between neutral and the weak La Nina side of things. Moving on to the Pacific Decadal Oscillation, nothing really has changed. It's just gone further into the negative phase. As a note, though, the October value was the lowest value since the mid-1950s. The Atlantic Multi-Decadal Oscillation, I have no notes on this. There's just nothing that's really changed since October. Sunspot Count, same deal. Nothing's really changed significantly. Then the conditions going into December, the peak gust so far has been 45 miles per hour. If that does not go any higher, that would be a forecast hit based on my peak gust forecast in October of 45 to 60 miles per hour. We have experienced the third warmest November on record. If you adjust for climatic trends, that would only change it to the fourth warmest November on record. And then we have so far experienced 10 inches of rainfall. That's going back to, I think, December 1st is when I got that. We have seen some since then, including this windstorm that got us that 45 mile per hour gust. There are some statistics I take into account with those last two specifically. So looking at the analog years and the statistical trends. I trimmed down the amount of analog years I had from, I believe, 19 down to 14. And I also changed one of my top analog years. So, my top analog years, 1929 to 1930, 1971 to 72, and 2009 remain. However, I swapped the 1962-63 top analog year for 1956 to 57, as I feel like it better exemplifies the conditions we are experiencing this year, especially with that super negative PDO values. However, I did keep 62-63 in the analog year data set. So, the average winter temperatures among these analog years, they're about a titch below 41 degrees. That's about a degree below average, while the top analog median is 39.4 degrees below the all analog median. The water year precipitation did go up for the all analog median from the October forecast. It is now at 35.3 inches, still below average, but not as much as it was in October. However, the top analog median did drop to 29 inches, which is a reason to be concerned. However, I did find a statistic that could counteract that, so we shall see. The adjusted snowfall totals did go up from October. The median is now 5.8 inches. This is compared to a long-term average of about 4.3 inches and a long-term median of about 3 inches. The top analog median did not change. That remains at 7.8 inches. So to compare the top analog years and why I chose them, the ENSO states pretty much agree on every year with the exception of 56-57, which fluctuated between a neutral and a La Nina state. PDO agrees on every case. 1929-1930, however, was a little more neutral than the negative phase we are seeing now. It also just randomly flipped between positive and negative every year for some reason in that time period. AMO, the only year that didn't agree was 71-72. And then the sunspot count, 56-57, despite being far above the current sunspot count, it was actually in the same point in the sunspot cycle as right now, and that's more important than the actual sunspot count. So I do take that into account. It was just a rapid rise in that sunspot count. So, some highlights from these top analog years. Record events in 2930 included the longest Arctic blast in Portland's history. 56-57 had the second longest Arctic blast in Portland's history, also occurring in the same month of January. Then 2008 to 2009 had that historic December with 19 inches of snowfall. Each year had at least 5 inches of snow or more, unadjusted. And while 71 to 72 was the most benign winter, it was still pretty active by Portland standards in terms of our wintertime conditions. So, here are some statistics. I am adding a few that I did take into account from October, but I cut due to time. Because this is a YouTube video, I am not constrained by time. So you're going to hear most of the ones I took into consideration. The ones I did not take into consideration, I left out of this. So, 4 winters in a row have failed to get below 20 degrees. This is now tied the record, and the chance to exceed 4 inches in a row is at 3%. Adjusting for climate trends, you're at about 5%. Only 3 winters have produced a temperature under 20 degrees with less than 1.5 inches of snow. All 3 of these winters had no snow winters. I am only going back to 1940 instead of the 1900 because that's when the Portland airport data started. That's the official data site for the Portland area. The second La Nina almost always contains a drier winter than the first. Out of 11 pairs of La Ninas, only one of them was wetter the second year compared to the first since 1950 when the Oceanic Nino Index started to be tracked. Last winter, we did experience a slightly above average winter. The reason why we are in drought is because we had a historically dry spring. And because of the historically dry spring and the fact that fall and spring do not have a clear trend, that does give me a good reason to hope, at least, that we'll be significantly wetter than last year, though I am not calling for a hyperactive year by any stretch of the imagination. So, part 2. The chance of measurable January snow for the first time in 5 years, we will tie the record if it doesn't occur, is over 96%. That is adjusted for climatic trends, by the way. And another thing I found interesting, and this one I added for the December update, is that in recent years, February has actually been colder than January for 4 years in a row, which has doubled the previous record. So the odds of this happening is 0.02%. The chance of a seventh, I'm putting this next statistic in here more for reasons, even though it is overwritten by the under 20 degree snow statistic. The chance of a 7th winter in a row, which would tie the record of measurable snowfall, is 10.8%. However, again, I do not take this into consideration because it is overwritten by the under 20 degree snow statistic. However, watch out for next season though, because assuming the under 20 degrees happens this year, that could make next season have no snow at all. The chance of a 5th consecutive year, which would be a record high, below 32 inches of precipitation, is 0.1%. However, I take this one with a little bit of a grain of salt because I notice in the data sets that the rainfall tends to be in streaks, not in like 1 year above average, 1 year below average, just like 5 years in a row of above average, then 5 years in a row of below average. But because we've already doubled the previous record, I am reasonably confident it will be above 32 inches this year, which means I will be raising my water year precipitation forecast from October. The last two statistics I'll go into, of the 14 years I had an 18-inch water year so far on December 31st, 13 of them got to 40 inches or higher. This is a possibility, but I don't think it's going to happen because at the start of December, 10 inches have fallen. 6 to 8 inches seems most likely for the month based on forecast models. This is almost a prerequisite to get to a hyperactive water year, just FYI. Then of the 6 warmest Novembers on record before this year, 5 of them have contained 8 inches of snow or more. None of them contained no snow. 5 out of 6 were also La Nina, showing that this past November actually wasn't untypical. There was also a heavy January lean noted in these years, and 2008 and 2009 and 4950, the third and first snowiest winter on record, were 2 of these 6 warmest Novembers. So, it is now time to update the official predictions. As always, I will be starting with the water year totals. I am raising it, not by a whole lot though. I'm now saying a near average water year is favored anywhere from about 32 to 40 inches. That's from about 85% to 110% of average. Winter, I do not think we'll have more than about 15 3/4 inches. My best estimate's also raising to account for the higher all analog median and the statistical analysis as well. Temperatures, I am saying below normal is still favored. I'm also dropping my temperature forecast to say that it'll be anywhere from a degree below average to 6 degrees below average. My best estimate is about 3 degrees below average. As a note, that 6 degree below average, if it does happen, would be the coldest since I believe 1949 to 1950. Again, I don't think it'll necessarily be that cold. I'm looking around 3, but it is something to keep in mind. Windstorms, peak gusts, I am lowering the ceiling of my peak gust forecast from 60 down to 55. I am keeping the bottom at 45 because I would be stupid not to if it has already verified. This might be an east wind gust instead of the typical south wind because based on one of my next predictions, an Arctic blast tends to bring stronger east winds. Lowest temperature is, I'm still expecting it to be below 20 degrees at some point this winter, with an enhanced chance of a Arctic blast, possibly a major Arctic blast. My best estimate is still 11 degrees. Then my estimated peak time period is December 20th through the end of January. So, on to the more snowfall forecasts. Mountain snow depth on April 1st is between 90% and 140% of normal. So, great setup for the water supply year and a pretty good ski season after a later start than normal. So, for valley snowfall, I am thinking it very well might be a hyperactive winter, possible at least. I am removing the ceiling on the valley snowfall forecast because this is likely going to be in the top third of all winters. 6 inches or more, regardless of location now. The best estimate, I am still going to be dividing up though. So if you're anywhere north of downtown Portland or related locations, I'm thinking about 9 inches is the best estimate, with about 1 to 6 snowstorms depending on how big they are. And then for anywhere south of downtown into the central and southern Willamette Valley, I'm thinking the best estimate's about 15 inches. Now that best estimate, I will mention for full clarity, is a all analog median or the top analog median of Salem. And the chance of snowstorms is listed below, and I did lower the chance of a bust winter to account for the November snow statistics. So, that is it. Thank you for listening. And then, if there's any significant weather events, I will come out with shorter term weather forecasts, and of course, I will come out with a verification of this sometime in the March time frame whenever I have time juggling around school and all. Otherwise, I will talk to you all later, and take care.